All right. The next endocrine structure we want to address in the lab today are the adrenal glands. All right. They're what we call suprarenal because they are superior to the kidneys, renal meaning kidneys. And they're small, fairly innocent, insignificant looking little structures, but very, very important to our function. And of course, they're, like many of your structures, are divided into regions. And like many of the structures in the body, we have a cortex. I said the outer because cortex means bark, and an inner, a medulla. And if you're not used to this, the medullary area of most structures or organs is usually easy to identify because it's less organized. It's often where the blood vessels enter and before they begin branching into their capillary beds. And so in order to accommodate the larger blood vessels, it's just not as well organized. And this is very much true for the adrenal glands. Now, and if you're not used to this already, you'll also realize that glandular tissue takes on a specific appearance in most of the models, and in fact in your body. And I often describe this as the cottage cheeses, because here's the pancreas we're going to talk about next, and the adrenal glands, very similar. They get this appearance because they have this network of collagen fibers, more reticular fibers, that kind of give support to the cells, but the overall structures, and therefore they kind of get divided up into these little like cross-hatchings here, that I often say looks like cottage cheese to me, or curds. But this happens because, the glands are mostly secretory cells. Majority of them are epithelial cells, like you learned in A&P1. And for that reason, the whole structure itself doesn't have a lot of support. There's not cartilage, there's not bone. We have to have some connective tissue to give it organization and support, but the majority of the structure, like adrenal glands or pancreas, are going to be the cells, the secretory cells themselves. Right? So the adrenal glands, shown here, and in any model that you have a kidney, you're typically going to see the adrenal glands. They make, in the cortex, we have 3 basic groups of hormones we would like you to know. And we consider all of these steroids, by the way. We have the mineralocorticoids, we have the glucocorticoids, and then we have the androgens. Right? And andro means male, so the androgens, male generating, they're sex hormones, if you were, minor players before puberty. Right? After puberty, testosterone, estrogen, progesterone take over the majority of the sexual function and identity. So the cortex makes these 3 groups. And the mineralocorticoids, the one we're going to spend the time talking about and talk a lot about in the class, is called aldosterone. And again, that's steroid. And aldosterone, mineral, because it controls the levels of salts in the body, mostly sodium and potassium. All right? The glucocorticoids, the main one we're going to talk about, is called cortisol, and glucocorticoids because it regulates glucose trafficking or glucose usage in the body. Right? Many people might already realize that cortisol is what we call the stress hormone, and of course in stressed states, this is an energy expensive or using state, sometimes called a tissue wasting state. So cortisol is going to have a function, right, made by the glucocorticoid, the cells here that make glucocorticoids. Right? So these 3, each of them triggered by different events. So the mineralocorticoids, aldosterone being the main one, is triggered by a change in the levels of sodium and potassium in the blood, or plasma more specifically. So when sodium levels are low or potassium levels are high, aldosterone, this is sensed by these cells as blood moves through it, and aldosterone is released as an answer to this problem. Because again, sodium and potassium are involved in neuromuscular function. We need to regulate their levels. The target then for aldosterone are the next door neighbors, the kidneys. Kidneys are the major target for this because kidneys regulate the substances we find in the blood. So aldosterone, if sodium levels are high in the blood or sodium levels are low, low sodium, high potassium, right? And when aldosterone is released, then you will conserve sodium, right? The kidneys will not pee it away, and you will secrete and excrete then potassium. Now, glucocorticoids control cortisol being the main one. They regulate the use of energy, and specifically the use of glucose. So cortisol is going to have an influence on the main tissues that are responsible for either storing or producing substances, energy-rich substances. So we would consider the liver, there's just a piece of it here, right, as a target of cortisol. We'd consider muscle and fat. These are liver, muscle, and fat, or adipose, are the three major targets of any energy-regulating hormones. Right? So cortisol is released also in stress states, so it helps you conserve glucose. It decreases your use of glucose and switches to a use of other alternative chemicals like adipose, right? Fats. Right? And then androgens, again, they target pretty much your sexual characteristics. So if androgens were overproduced in a male or female, they would take on more male characteristics before puberty, maybe hair growth and muscle, as an example. Now, the medulla, the inner part, you can't see here, we'd have to cut into this to see this. The medulla of the adrenal glands, right? This makes two almost identical hormones called epinephrine and norepinephrine. And you were exposed to norepinephrine in A&P 1 because norepinephrine, oops, let me get this down here a little bit. Norepinephrine is the neurotransmitter used by the postganglionic neurons of the sympathetic nervous system. So whenever the sympathetic nervous system, or division of the autonomic nervous system, the sympathetic division, is activated, the fight or flight, you will have the adrenal medulla, the medullary cells here, will be activated to start making and releasing epinephrine and small amounts of norepinephrine as well. And so you just kind of begin to identify that anytime that there's an activation of sympathetic system, that the adrenal medulla will be activated as well to help support that function, that fight or flight. Increased heart rate, increased breathing, dilation of the bronchioles, dilation of some blood vessels, constriction of other blood vessels, right? Increased heart rate, blood pressure, etc. Anything to get you moving more efficiently and effectively, right? Now, we have a slide of the adrenal gland. I don't typically test students over it. It's a small mammal that this came from, so it's a cross-section through the whole thing. I have this under very low magnification here. Let me see if I can get this, skim over it. Okay, stop, again, boom. All right, and so here's the outer, right, capsule part. So the cortex actually goes from here on down to here. There's a much lighter area that's pretty distinctive when you look at this under the microscope. That's the medullary region. And so this is actually the cortex from about here to here is divvied into three regions. There's there's a fasciculata, the glomerulosa, and a reticularis, and they all start with zona. So zona fasciculata, zona reticularis, zona glomerulosa, right? And those zones, much like you use strata for skin, would be populated with these cells that produce, right, the mineralocorticoids, glucocorticoids, and androgens. So that pretty much covers what we need to be introduced with in the adrenal glands.